Check. All right, I think let's get started. There are a couple of people joining, or at least somebody's checking the door that they could get in. We have database enthusiasts on site. We also have people online. Hello, people on the interweb. Welcome to this meetup. So just before that, I quickly Googled for DBA jokes, and then actually the first one was quite good. 3 DBAs walk into a no SQL bar, and they soon leave because they couldn't join a table. But jokes aside, a few years ago, we were already at the very big scale in terms of our database sizes, the number of users, the number of requests. And one of the problems that we had been running into was having efficient database queries. And of course, like overall, the strategy is let's divide and conquer. Let's shard the servers. Let's split them up into smaller chunks and then get them to perform again. And what happened was that we, of course, did that, but some databases still grew a lot, and we just couldn't find the time to split them up. And then we were looking for alternatives. And we tried many different technologies until we found TiDB. That was roughly a year, and let's say a year ago or a little bit more. And we finally saw that we have a solution to our problems, which is a product solution rather than us having to do more and more work with our divide and conquer approach. And this is when we started using TiDB from PingCAP, and we got our first databases live during this year. So I'm actually very happy to introduce Ronnie from PingCAP to tell you a little bit about their company and their technology, and later on followed up with technical talks from PingCAP and also technical talks from Bolt. Thank you everyone for coming, and I'll give it over to Ronnie.
Yes, hi all. Thanks for being here. My name is Ronnie Salovaara. I work as an account executive for PingCAP, covering actually the whole European region at the moment. And big thanks for Bolt for organizing this first ever co-meetup together with them here in Tallinn, Estonia. And you are the most welcome to participate for this event. So we have prepared good content for you to give you some extraordinary value, how Bolt operates TiDB, basic information of the company. So hopefully you will enjoy about the content and the meetup overall. But let me start with introducing the company. I think some of you might be familiar with the PingCAP, some of you may not. So PingCAP as a company was founded 2015 in Silicon Valley, when all the engineers, DBAs were working in the big tech companies, and they were facing the struggles of managing the way of that databases. They found PingCAP, company that now has more than 600 employees worldwide. We have a really strong foothold in USA, North America, Asian region, and currently ramping up the European business unit as well. 2021, we received, I think, one of the biggest fundings ever in databases industry from Round D, almost 300 million euros. And we currently operate offices across the world in Amsterdam, Silicon Valley, Beijing, Tokyo, etc. So good to be here, and please enjoy all of the catering, all the nice merchandise that what we have. And yeah, nonetheless, thank you. Up to you, Daniel.
Hello. So I'm going to give you an introduction to TiDB. I'm Daniel van Eden. So I've been working at PingCAP for quite a while now and have been helping Bolt also with making TiDB at Bolt a success. So the problem definition is maybe a good point to get started with. So a typical MySQL installation starts often with a single server, then you add some replicas to get redundancy. For example, if your primary dies, and then you add some replicas to increase read capacity. So on the screen, you can see the application server, like multiple instances, reading from a set of MySQL replicas and writing to a single MySQL primary. So the first problem you're usually facing is failover automation, because if this primary dies, you need to actually have something that promotes a replica, and then the primary that died, you need to replace it somehow. So maybe you want to restore a backup. So a lot of complicated things. Luckily, things got better in the last few years on the MySQL front with GTID. That really helps, with some other things that are like specific to MySQL 8. So they improved things a little bit, but not enough, if you ask me. So some cloud providers also have their own automation on like doing master promotion, etc. But this is very cloud specific. So if you move from one cloud to the other, things work differently, and it's all like a custom add-on. Also, like switching from one primary to like a replica usually takes quite some time. That can easily be multiple minutes. So that's not great. And then we have the problem of stale reads. So replication is asynchronous. So all the writes that are going to the primary will eventually end up in the replica. But that means that if you're writing a row to the primary, then reading it from a replica, it might not have arrived there yet. So there are a few common solutions. The first one is to just always read from the primary. Well, that only gives you one machine. That's not a really scalable solution. The other thing you could do is to retry the read after a number of seconds or milliseconds. That may work, may not work. Read from a replica, and if that doesn't work, you read from the primary, which is a really great way to do a denial of service attack on yourself. Because if there's any replication delay, then suddenly like everything starts to read from the primary. There are some other ways, like you could be using GTIDs, which might be a slightly better way, but quite complicated to set up correctly. So yeah, not great, but there are some solutions. Then there are schema changes. Well, everyone needs to do schema changes, because you might want to add like a column, you might want to add an index. These things are quite normal. With MySQL, this can actually cause operations to block. It can cause replication delay. So the solution is to use an online schema change tool. There's PT OSC from Percona, and there's Ghost from GitHub. These work quite well, but they're not very efficient, because they always make a complete copy of their whole table. And of course, it's an external tool, so it's difficult to automate. And then if you have some ORM, for example, it might be difficult to get the ORM to play nice with your schema change tool. Write capacity. Well, if we have a single primary, that's limiting the number of writes you can do concurrently. MySQL 8 has a group replication with a multi-primary mode. However, that's not really recommended, and has like all kinds of minor issues, and still you're writing all the data to every server. So the eventual scalability isn't really that much better. Scaling, we want to both scale reads and writes. So with MySQL, there are no simple solutions. If the data doesn't really fit anymore on any server, then you have to do something like sharding, either by function or just on a range of customer IDs. Not great. And resharding is often the hardest part. So you decided to shard based on customer ID and you want to have more shards, and then you basically have to start all over again. So that's not great because it puts a lot of extra work on application developers. Also, when you're having shards, it also means that your analytics are going to get way more complicated because you have to run every query in multiple parts because you want to like summarize all the data from all the shards together, and that gets really complicated. So, of course, the solution is TiDB, as you might have expected. So how are we fixing this? Well, failover is built in. Failover is fast, like less than a minute, probably maybe even less than a second, but like quite quickly. We don't do stale reads. You just read the data from any of the servers and it will always be up to date. So no replication delay to take into account. All the DDL operations are online. So just run your alter table, just let your ORM run your alter table. That should all be fine. So that really makes things easier to do. And for write capacity, just adding more machines and the cluster scales, and you can take more writes, more reads, everything. The same is true for scaling, just adding machines. That all works. And one bonus item. So many people are running just MySQL and then doing some ETL to Hadoop or some other like BI system like Redshift or whatnot. It needs a lot of work to maintain the ETL job, maybe do a daily export, and then your daily export means that all your reports might get outdated data from like a few hours ago. So that's not great. And with TiDB, you can run the same workload on the same database, both OLTP, OLAP, on the same database, and then you have real-time data. And that's what we are calling hybrid transactional and analytical processing, also known as H-step. So TiDB is written from scratch. It doesn't share any of the old code of MySQL. There are multiple components. The first one is TiDB server. This does the SQL parsing. It does not store any data. Then there's TiKV, it's a key value store. This actually stores the data in a row-based format. Then there's PD. This is called the placement driver. It's a very small component that just takes care of management of the cluster and handing out timestamps, which is needed for transactions, etc. And then there's an optional component that's TiFlash. That's what is providing the 8-step functionality as I just described. So this is basically what a cluster looks like. TiDB getting your SQL queries, contacting one or more TiKV servers on the right that are doing redundant copies of your data. Maybe also have some row-based, column-based storage on TiFlash. And then PD is there to just manage some of these things. We do support multiple availability zones. So what we do is we take a table, like in this case, the orders table. We divide it up into multiple data regions and distribute the data regions over the servers that are in multiple availability zones. And then when you're running your query on one of the TiDB nodes, it just knows which region to contact, and it will always contact the leader of that region. And if it needs data from multiple data regions, it will just contact multiple data regions. So for TiFlash, we are still storing all the data in a redundant format, but we are storing also a single copy of the data on a TiFlash node in columnar format. That's kept up to date, so it's all in sync. Your queries don't need to be written any differently. It will just start to perform better, especially for analytical queries like a sum over a whole column, or other cases where you only need a specific column, and most of the table for that column. We also do push down of conditions. So if you, for example, do a count star, every data region will do a count star basically, and then sum up the total in TiDB eventually. We have a few tools, of course, because just a database is not enough. You need tools to export data, import data, backup, restore, to stream changes to Kafka, for example, migrate data from MySQL and back. And now for a quick demonstration, we wrote a tool some time ago called OSS Insight. We stream GitHub events to there, so there's quite a high write load, or just all the events that are happening on GitHub, like new pull requests, new issues, new comments, new whatever. So those are all written to the database, and we allow people to just run this interface and then query all the data, see statistics, and it's all in the same database. There's no like analytical part of the database, operational part of the database, just one database. So we're not using any ETL, all the data is real time. The tool just looks like a normal tool and it's really useful even without knowing anything about TiDB, but you can actually look at the SQL we're doing and click on the explain to actually get an explain plan in the interface. So this is what it looks like if you look at Microsoft Visual Studio Code. You just get a lot of the information about this project. And then you can just click on the SQL button and see the actual SQL query that it's doing. And look at the explain plan. And then you can see that it's using the columnar store and it's using a parallel execution. So this is a quite useful thing to look at, just as an example to see how TiDB allows you to like quickly build something like this and work with like analyzing large amounts of data that are continuously changing. That was the introduction. Any questions? Yes, so I think Ronnie or Elwin will give you the microphone so you can ask the questions because we have people online. So you need to actually ask a question on the microphone to make sure that they also can know the question.
Oh, thanks. I more or less understood about the technology. Can you please tell us more about what level of service do you provide, like as a company? So
yeah, sure. Mm-hmm. So we have TiDB Cloud. It's our own cloud offering. It's available on AWS and Google Cloud. We also have an enterprise version, so you can deploy it on whatever thing you want, on Kubernetes, on a different cloud, on your own systems. And TiDB is open source, so even if you don't want to pay us, that's also possible. You can run it yourself, but then you don't get support, etc. Does that answer your question?
Yeah.
Okay, more questions? Okay.
Thank you. Hi. You mentioned Apache Kafka. What would be the use cases of streaming there?
Yes, so we are streaming data from TiDB to Kafka. Can be for anything. I think in the Bolt presentations there will also be a few mentions about this because that's, I think, one of the things Bolt is using. But it's just like any data of that's changed that's going to streamed into a Kafka.
Kristo from Wise. So we have like 400 databases and would maybe not want to put them like all into one ETL or a TiDB cluster. Could we run like ETL on top of all those databases? Does it support something like a distributed query engine in that case, or what would be like the solution for that problem?
So if you're running Kubernetes, you could run multiple smaller clusters. That's one possibility. And with things like DM, you can stream data from multiple sources into one maybe bigger source. So that's what some people are doing. They have like, say, 10 different MySQL databases. From those databases, they are replicating the data into TiDB, and then they are doing analytics. That is all possible.
Okay. One more question. So about this, so you said there is no stale reads
Correct.
in TiDB, but that's effectively being achieved by synchronous replication between the different availability zones, right?
So data is always written first to the leader and only acknowledged after, I think, written to at least one of the other replicas. But one of the things that we're doing is that we always read from the leader of a region. And what we are using for this is Raft. Mm-hmm. So if you know how Raft works, that's basically what we're doing. One of the things that is a bit special about how we're using Raft is that for TiFlash, we have TiFlash that's always in the mode of being a learner, so that never gets to be a leader.
Yeah, but at the same time, to get the consistency, you need to ensure the data is replicated kind of across at least some amount of Raft members, right?
Yes, so I think by default we have 3 copies. Mm-hmm. So it's written to a leader and only acknowledged if it's written to at least one replica.
So that pretty much the right penalty on latency, right?
Yes, so it's written to one of the availability zones and then to a second one, because then you have the majority.
So and how much you estimate this right penalty latency, because you are using multiple, you're doing the replication, synchronous replication across Raft members?
I don't think there's much like of a real big overhead.
Mm-hmm. What about this? Sorry, one more question. What about this? So do you do like this? And you said there is no stale reads from TiFlash as well. Means you're, or you allow stale reads from TiFlash from columnar format?
No, it doesn't really do stale reads. So it's a learner mode. So that's how it keeps the data in sync. But also the PD that's giving out timestamp. So every transaction has a timestamp. Data has a timestamp. So based on these timestamps, it just knows to maybe wait or slow down things to make sure that the data is always consistent. So basically, the whole system itself takes care of the consistency without putting any load on the developers that they have to take care of, like replication delay.
But if you want your columnar store to be consistent with row store, right, you would need to still take this penalty of latency to transform data to row format, right? To columnar format, which is normally being expensive operation.
Yes, but I don't think for our case it's too much of an expensive operation. So of course there can be a bit of a delay, but your normal write load I think will never really slow down.
So you allow the stale reads from columnar storage means?
No, I don't think we allow stale reads from the columnar store. I think based on the timestamps of the data, like the TSO, it might make sure that it does the right thing. So I think we need to go into much more detail than I think we have time for now, because not sure how we're doing with time.
Hello. Question about these exports to Kafka Pulsar. So it is done by means of TiDB, some adapters. You can add your own adapters, or
yeah, so
what it is?
TiCDC, that's just a service that you can add to your TiDB cluster, and then it can stream to different formats.
So basically like more complex trigger or something similar, and you can add your own those export tools, yes?
Yes, and like we also have like data migration, and both TiCDC and data migration have just multiple instances to make sure that they're redundant, that if one of the instances just fails, that it just continues to stream.
Okay, thank you.
Okay, I also have some questions from the online audience. Some questions has been already covered, so there is one. Is there resource isolation per schema?
I don't think there's current resource isolation per schema. I think that was something we are working on, but I would need to look that up to confirm that.
Okay. And there's another question about the values brought from TiDB to Bolt. I think these will be shared in great details later. Any more questions from the online, offline audience? The people who are sitting here. Any more questions? We can take last one.
Let's do one final question and then we continue with the next speaker.
Hi. Are there any plans to support other dialects besides MySQL?
No, there are no any plans that I'm aware of supporting any other dialects. I know that there have been community projects doing things like that, but currently I don't think that's something where we would really get the right level of customers that are really using that.
Just a tiny follow-up. Is the the overall amount of customers the main reason why you're not interested in that, or are there any technical reasons for that?
It's usually a quite complex thing to do, especially if you want to combine both dialects. For example, say MySQL, Postgres, or maybe an Oracle dialect. So it's quite complex, and then you need to have like a really good customer base to actually make that worth the effort. So it's complicated, but it's open source, so you can do it yourself if you want. Be happy to take contributions as well. Thank you all.
Thank you, Daniel. It's great, good to notice that you have plenty of questions, and in sake of time, all the questions that cannot be answered will be followed up after the event. So nonetheless, let me introduce our next speaker, Andrei, to the stage.
Okay. Hello, everyone. Let me introduce myself. My name is Andrei Fedorov. I'm working as a database engineer here at Bolt, and besides other things, I'm working on migrating to TiDB and also supporting the existing TiDB clusters. Few words about the company. As you may have heard, we are one of the fastest growing technology companies with more than 100 million customers across the whole world in more than 45 countries, more than 500 cities, and we did grow more than 3,000 employees already. Our product portfolio includes 5 core products. That's ride hailing, scooters and electric bike rentals, food delivery, car sharing, and grocery delivery. Few fancy numbers. So we're very serious about migrating to TiDB actually, even though we still have 65% of our data in MySQL, already 35% are migrated to TiDB. And also all the new schemas that our developers are requesting are going to TiDB as well. So no exceptions, everything goes to TiDB now. Why did we decide to move from MySQL somewhere else? Why did we look for alternatives? So as every growing company, we had our pain points. They are not something special, but the most important ones are the data size. We did grow, well, even though MySQL performed very well and still performing, we did grow up to the point where we hit all kind of limits of MySQL. So the rate of the data growth is also enormous, and this causes not only the costs for the storage, that is not the most efficient one in MySQL, but also the operational issues like backups and recovery are taking just too long, and schema changes are just too slow. They may take days, weeks, or even be impossible at all at some point. why did we choose TiDB, not something else? Well, it has so far the best compatibility with MySQL, MySQL protocol, and also our internal systems. It is open source. It scales almost infinitely. It does automatic sharding. It's well, and the sharding is transparent to the applications as well. All the nodes, TiDB servers are writers, so you don't have the pain of switching masters anymore. And that's another level of availability, actually. It has more efficient storage engine, RocksDB, that has good compression. It is cloud native and runs very well in popular clouds and even in Kubernetes. It has ARM support, ARM architecture, and it is very well documented. And if it's not enough for you, you can get paid commercial support for it. A few words about our MySQL infrastructure. So it's a typical primary replica setup. So single primary and multiple replicas attached to it. We run it on AWS EC2 instances with Intel architecture. So it's traditional x86. We use ProxySQL for connection routing. We use Orchestrator for monitoring and managing the topology. We also have automated master failover in case of failures. We have built a custom user management system in-house. We use PMM, but we also built a lot of custom dashboards for it. We have dozens of Ansible scripts to manage our clusters. And also we stream the data to Kafka using the Debezium connector from MySQL. With TiDB, we're deploying it using TiApp tool, the native one, to AWS EC2 instances, but this time we're using ARM architecture that allows us to reduce costs and get more performance for the same money. TiDB also works behind the ProxySQL. We still use it for connection routing. We apply infrastructure as a code best practices, so all the infrastructure is terraformed. We even developed custom modules to manage TiDB and data migration clusters. So it produces the necessary set of instances and also the topology files for TiApp, so we can immediately deploy if we need. We use local mirror since our database are isolated from the internet for safety and security. And thanks to TI/CDC component, we can stream the data to Kafka for our data lake directly, not using any third-party connectors. We did a lot of preparations for the migration. We did long prototyping and proof of concept stage. At that stage, thanks to our application tests, we discovered issues with some queries that been not compatible or not working on TiDB. We also discovered some bugs. In particular, there was a time zone conversion bug. We did use oversized setup initially, just in case some query requires too many resources on TiDB, we would like to feel safe. And we did a lot of work on internal onboarding. So we developed our own training, internal one for the basics. And also we requested a on-site training from the PingCAP for more advanced stuff. We had to build a lot of tooling, and we are still working on that. In particular, there's a custom AMI image that has already all our internal tools, all the necessary operating system settings, pre-installed software, and so on. So it is easy to deploy everything. We have a live traffic switch tool because there's need to have some safe, fast, and reliable way to switch the traffic from MySQL to TiDB, just in case. And my colleague Susanna will tell more about that in her presentation. We have developed cluster preparation tool to set up the cluster metadata and ProxySQL configuration as well. we have built a scripting, so to say, enhanced backup tool, because the native TiDB BR tool is missing index statistics backup. There is no history of backups, and so on, some smaller things. We're working now on data migration automation tools. So far, we implemented scripts for DM tool, but Lightning and Dumpling are still in progress. Also, we had to prepare a good plan B, just in case something is wrong after the migration. Monitoring, well, with monitoring, there was a lot of work as well. So we discovered that the default settings of the monitoring are a bit noisy, so we had to fine-tune them a lot. We also developed Ansible scripts to manage the alerting rules for different clusters. We developed a custom page based on tie-up utility that provides the links and overview of all the clusters we have and all the links to all the dashboards, Grafana's, Alert Manager, and so on, and also the list of all the schemas in each cluster, so you don't have to guess where your schema is. We have also enabled remote writes from the TiDB monitoring to our company-wide Prometheus, so we have highly available setup with infinite retention time. And also the table and schema specific metrics were missing in the stock dashboards, so we developed our own exporter and dashboards, and my colleague Anders will tell about that more. Plan B. So if the replication, well, if the migration for some reason, well, succeeds, but after that we notice that there's degraded performance or functionality of our applications, we need something where we can fall back, basically. And for that purpose, we use MySQL cluster, MySQL replica cluster behind the TiDB cluster. However, we faced quite some challenges setting it up because it takes a lot of time, and the replication is not always stable and fully reliable, because you can easily break it with DDLs, and initial replication catch-up takes quite some time. So it's basically a little bit difficult to keep it alive. We used several migration scenarios. It was a double write mode. It's basically when we have a set of services that are writing both to TiDB and MySQL. So we have two identical data sets in new and old databases, but the reads are performed from the MySQL, and at some point we just change like the source for the reads and start using TiDB for reads. That is very safe and reliable approach, but requires quite a lot of development and is not applicable in every case. So for most of the migrations, we use direct traffic switch scenario and plan B. So we just change the proxy SQL rules and start routing the traffic, both reads and writes, immediately from MySQL to TiDB. So Leander will tell more details about this scenario that we used to migrate from Vitess. During the migration and first months of use, we have quite some findings that may take hours to tell about all of them. But we'll share a little bit. Many of our applications rely on order by ID, where ID is auto-incrementing primary key. But in TiDB, this approach no longer works because auto-increment is monotonic but not consecutive. Well, we have several, usually in a normal setup, we have several TiDB nodes. All of them are performing writes, and they are allocating a cache of auto-increment ranges. And because of that, you may end up with interleaved values that are, yeah, they are monotonic, but they are not consecutive. There's a mix of somewhat different values. We found a workaround immediately to use precise timestamp column for that. But TiDB is also announcing that next version will get a solution for that as a centralized auto-increment ID allocating service. So basically, you disable this cache, and every new auto-increment value will be issued from this service. Big integer and auto-random. Auto-random is an extension of auto-increment, but it's designed to avoid write hotspots in the database by being random and evenly spreading the writes across all the regions of the database. But unfortunately, the JSON specs don't allow the number to be bigger than 53 bits. But if we use a big int auto-random, it immediately generates values that are in the whole range of 64 bits. So it produces application errors and is not pleasant at all. But PingCAP already implemented a feature to limit the range of allocation of those random values. Another interesting thing we faced is the cross-region replication. As we demand ultimate reliability for our systems, we would like to have a replica TiDB cluster in another region for the case the whole region of AWS goes down. This has happened before, actually. Not with us, luckily. So when we tried this setup, we faced an issue that under some specific workloads for few of our clusters, the replication cannot catch up. There's a lag and it is growing. You cannot do anything about it. But then we found a workaround with help of PingCAP that it is possible to move the ICDC nodes to the target region, so to be close to the replica cluster. This way it works well, but then another problem arises. Well, that we have other replication tasks running on TICDC, and they may anytime migrate to these nodes that are in another region, and this will generate a lot of cross-region traffic that is pretty expensive. Avro support. So there was a question about why we use Kafka. We use Kafka to stream all the changes from the databases into our data lake that is used for analytic purposes. For different reasons, we did choose Avro format for us, in particular because it is supporting to have a schema inside, and it is easy to work with it if your schema changes frequently, which is the case here, actually. And early versions, early 5x versions of TiDB that we started to use had only experimental support of this format. Some things were missing, some things didn't work at all. So after some discussions, PingCAP decided to implement like full production ready support of Avro, and yeah, it really works, and we are using it now. A few more interesting findings, briefly. So when before on MySQL infrastructure, we've been mostly using internal NVMe storage or storages of the instances to have more I/O performance. But TiDB is cloud native, so it's very well optimized for cloud environments and EBS drives, so the network attached storages. It performs really well on it, and you cannot actually see the difference with NVMe in most of the use cases. And another thing is it's just difficult to manage storage nodes running on internal ephemeral storage that goes away if you like stop the instance or change the instance type. But with EBS, it works flawlessly. Compression, after one of the migrations, we've discovered that our data was compressed 10 times compared to MySQL data size. That was really impressive, like 10 terabytes in less than one. But more common is to see something like 3 times compression for most of the data. Configuration. Well, the last thing I will tell about. So the initial provisioning of the cluster may be simple because you just follow the manuals, all good. But then once you need to change the configuration, especially the advanced things, it may start to be painful because you have to tweak here and there. Configuration is spread across server configuration, global variables. You need to use multiple YAML files. Some components have different set of settings, like logging is different for TiDB and for DM. Some things cannot be configured, like retention time for ng monitoring component. Migration needs a huge set of configuration files and command line parameters. If you need to disable telemetry, you have to do it in 3 places at least, maybe more. Yeah, that may be painful. So far, that's it. We have a few minutes for questions if you have some.
For example, yeah, 1 second.
Thank you. Hi, my name is Victor. I have a question. Probably it's just maybe like a general one. Is it possible to compare this TiDB solution with the Percona XtraDB cluster, or it's something different?
It's something different. Well, there are like seemingly common things like multi-master and so on, but it's really different thing because as Daniel mentioned, TiDB is written from scratch. It doesn't share any code with MySQL.
Ah, okay. And like maybe in a few words, so TiDB provides like better or more features, or it's like completely different area?
I would say TiDB is for bigger scales, first of all. But that, well, it doesn't mean you cannot run TiDB for smaller scale, of course. Another thing is that, the storage and SQL layer are decoupled in TiDB, so that gives more flexibility, more features, more opportunities. So I would say that TiDB is just better, but
it depends, yeah.
Yeah, it depends.
Is it allowed to ask one more? Okay. And another thing I wanted to ask is like, did you have some kind of benchmarking for what will you gain from the using TiDB? Or maybe I missed one. I came a bit late. But so you mentioned that you were performing this testing before you will migrate completely. And was there any specific numbers or something like that?
I would say that we haven't been looking for some huge performance gains. Well, we didn't investigate it that much. So we've been interested to have a consistent performance for our application. So consistent latency and so on. So basically we did only basic benchmarks to see that it performs at least as good as MySQL. But the things like sharding, automatic one, the infinite scalability and so on were.
So it was more about features and not overcoming the thresholds of the MySQL.
Yes.
Okay.
Yes,
all
but
right.
that doesn't mean that that TiDB is not I guess Daniel may tell more if there are some numbers, if TiDB is much faster or comparable to MySQL or.
Nope. Doesn't work. But probably we can hear you. There is a Zoom. Okay. All right. Yeah. Yeah. Thank you.
Okay.
Yeah. So for the people online, using a microphone is, I think, really good. So we do have some performance numbers on our website for like different tests, but of course, if you're testing against your environment and your application, you can see all kinds of different numbers. Of course, with TiDB, there are a little bit more components involved. So very simple queries. That's not really the strong point of TiDB. When the data size really outgrows on what you can store on a single server, then you really see the performance getting better. And that's also what you said with Percona XRDB cluster. There, all the data is stored on every node. So if you have more data than fits on a single node, Percona XRDB cluster doesn't work for you, TiDB does. And otherwise you have to go for sharding, and then you have to solve it in your application, and that's adding quite a lot of work.
Thanks. I have two questions actually. First one is, do you know why Bolt chose MySQL to begin with?
Well, that's historical reasons, I would say.
Okay, fair enough. And the second part is, are you ever worried that the horizontal scaling may run out, even though it's infinite apparently, that you may require additional vertical scaling?
Well, vertical scaling is not something that is not possible with TiDB, actually. You can provision bigger instances with more RAM and CPU if you need to. And also more SQL nodes, for example, that is more flexible anyway. So I think those limits are so far away yet. I guess we can grow up to them, then we will see what to do.
Okay, thank you.
I would really love to see you hit some performance issues, because then business-wise you're doing well.
I have two questions. The first question, did you somehow estimate or notice some reduction on cost of maintenance of the infrastructure with and so on? And second question, like, can you describe more like migration from MySQL to TiDB? So did you do it kind of in real time without of downtime, or there was small downtime when TiDB was full with data? That's it.
That's well, that will be covered in next presentations as well. But well, I will answer the second question first. Of course, there is some very small downtime, like some milliseconds or so, when we do the traffic switch. But that's it. No more. Well, regarding the first question, well.
For example, you could fire like few database engineers because there is no maintenance nightmare anymore.
Well, it's...
Or otherwise all database engineers became more productive, or there is some real savings in money.
Well,
if you compare managing the 36% of data in MySQL compared to 36% of data in TiDB.
It takes time to learn it. So at the initial stage, there is more effort required. But what we can see right away, well, the maintenance itself takes much less time. Because, you know, for MySQL, like failed instance is already a lot of work. You need to rebuild the replica, for example. Well, that's several hours of work and so on. For TiDB, it's basically nothing. Yeah, DDLs. Yeah, we have a huge amount of DDLs that we have to apply, and this takes so much time for MySQL. So we have basically more than a dedicated engineer for that. Well, I won't tell you the number, how many, but we have this. And for TiDB, all the DDLs are just instant and immediate. One command and it's done, it's there. So yeah, this definitely reduces our well, routine workload.
Okay, thank you.
All right, thank you, thank you, Andre. And due to the time, I think we need to take a cut off for this. And big hand to Andre for the presentation. And we have plenty of questions coming online as well. and a few was left unanswered. So every question will be answered after the event. So don't worry. But next speaker, Leandro, please welcome to the stage.
So hello, I'm Leandro. I'm a database engineer at Bolt. Today I'm going to be speaking a little bit about our journey from MySQL to Vitess and finally to TiDB. So why not just MySQL? We've covered this already, but basically we've outgrown, due to the fast growth of Bolt, we've outgrown MySQL. It's expensive in terms of operational issues. Everything takes longer with large tables. Some tables are multi-terabytes, so this is it has heavy costs for provisioning, for DDLs. Backups and restores also take longer, and data archiving. Even if you free up space in MySQL, if it's an InnoDB table, you're going to have to rebuild it anyway. So that gets quite painful. So we decided. Okay, another issue is write scaling. With traditional MySQL replication, you can't really scale write. If you want to scale, you can only do vertical scaling. So if you want to go to have more write capacity, you need to do horizontal scaling. And that means basically sharding and splitting your database into bits. We did try this, but it was complex. It increases complexity at application code. So because of that, we decided to try out Vitess. And what is Vitess? It's basically a semi-transparent sharding layer on top of MySQL. It works by having a VTGate proxy, which receives queries from the applications. And then VTGate will figure out which shards to route to and also consolidate cross-shard query results. There's also a topology server, usually based on etcd. And this has metadata information about the cluster and its shards. So yeah, this is also, there's a little VT tablet next to MySQL. It's a sidecar to manage some operations. So what was our main blocker to adopt Vitess? It was basically CDC for our business intelligence. Vitess didn't have a cluster-wide connector, so we had to write our own, and this was aggregating results at the proxy level, VTGate level. Once we wrote that, we were ready to go into migration. All the blockers were removed. So we ran Vitess for about a year. At the time, it was version 8 and 9. So I think the latest version's 15, 14, 15. So some of the things I say might be outdated, but this was the truth when we were running Vitess. So Vitess has a do-it-your-own kind of approach. They give you the pieces and you have to build your own tooling around it. It was quite a lot of work to do backups, provisioning. For example, there's no cluster level backup. You can't get a consistent backup at the cluster. You have to do backups on each shard. For example, for monitoring, we had to write our own Grafana dashboards. There were no built-in dashboards. So yeah, it took us a lot of work to run this. We also have a large costs for running a cluster in Vitess, and one cluster only supports one schema. So the cost in terms of EC2 instances was quite high. Either way, we decided to go with it because of the sharding benefits. So we migrated one of our largest schemas, and it had hundreds of gigabytes and a high growth rate. These were some of the challenges we had with running Vitess. First of all, the user management is not MySQL compatible. So you can't run grants, revoke, create user in Vitess. It has its own authentication system based on JSON. And this was a problem for our internal user management system. If we were to go with this solution, we would have to rewrite the system. We'd have to support both authentication mechanisms. And often there was no direct translation between the two. At the time when we first started running, there was no master failover. Eventually, they released VTOrc, which is a fork of Orchestrator, and that solved the automatic failover problem. But still, other problems existed. For example, DDLs were done at the shard level, not at the cluster level. So you could run into a situation where one shard would accept the DDL and another shard would error out, and you'd have out of sync schema definitions between your shards. Yes, also explain. You could do traditional MySQL explain at the shard level, but at the cluster level, you only had one tool called VT-explain, which was quite immature at the time, and the query execution plan output was not easily understandable, especially by developers, which were used to the MySQL format. And yeah, it was also not very easy to deploy at your local test environment. One schema, it was fine, but if you had multiple schemas, you had to do multiple deployments, and it was painful. So why TiDB? Basically, TiDB is distributed by design, and you have native horizontal scaling. So, oh. And this was one of the main reasons that led us to choose TiDB. If you want to scale up, you just add TiKV nodes or for storage, or TiDB nodes for SQL processing. You don't need any manual resharding. It has built-in failover, and it's multi-master. So it also has MySQL protocol compatibility. It meant we didn't need to do much modifications in our application code. Grants are basically the same. It supported our user management system. We didn't have to write our own CDC connector, and it comes with hundreds of Grafana dashboards for every metric you could think of. And also, like Andre and Daniel mentioned, online DDLs is almost instant. The only operation that takes some time is actually add index, but all the rest is straightforward. So before migrating, we had to do some testing. We spun up test environments for our devs, and they were also using tie-up Playground, which you could spin up a test environment on your laptop for 5-10 seconds. And the main problem we had was what Andre spoke about. We were ordering by primary key, and with order increments, it's not continuous. So the workaround that we found was to use created field. It's a timestamp field with high precision, so we would avoid conflicts. And we started ordering by that, and the problem was solved. We did some initial load testing, and we found the differences between TiDB and Vitess to be negligible. So 5-10 milliseconds, 5%, about that much. And with that, we were ready to make a migration plan. So here we see that we had 3 Vitess key spaces, basically 3 separate MySQLs. And we needed to pull all that data into TiDB. How did we do this? First, of course, we had to spin up the infrastructure with Terraform and tie-up, the PingCAP tool. And we used Ansible for monitoring configuration and backups. Then we did a dump win from Vitess, used Lightning to import it into TiDB. The Lightning process merged the shards into TiDB, and it also renamed the internal Vitess names. The schema names are different, and they're not very user-friendly. So it was renamed into developer-friendly schema names in TiDB. After that, we had to set up replication from Vitess to TiDB. And this was done using our data migration tool, which also did merging the shards and table renames, schema and table renames. And finally, we spun up a TiCDC mini cluster to support our data engineering team and have their Kafka feed working. What you see in the bottom is a plan B. So what would happen if our migration to TiDB was not performing, or we had to fail back somehow? The reason we couldn't actually switch back to Vitess was because there was no way to go from unsharded TiDB to sharded Vitess. So we decided to use a regular MySQL cluster for this. First, it was similar operation to loading the data from Vitess. We used Dumpin and Lightning to populate the initial data. And then for replication, we used TiCDC, which is compatible with MySQL. Initial challenges we had was actually loading the data. It took a couple of days, basically because this schema is a couple of very large tables and it has low parallelism. So yeah, loading took quite a bit of time. And then we had another problem, which was replication lag. Initially, we saw that it wasn't catching up, or it was taking a long time to catch up. And when you looked at the downstream MySQL, you could actually find deadlocks because of we only had two big tables. And the way around this was to actually reduce the CDC workers from 16 to 1. So that avoided deadlocks. And although it's counterintuitive, only having one worker allowed us to have replication catch up. So what did we do to prepare for the live switch? First of all, developers did some tests in their test environment. Things went great. Then we over-provisioned the TiDB downstream targets because we weren't very familiar with TiDB and we wanted to be cautious. So we threw extra hardware at it. Then we had to check if there was any replication latency spikes. We looked at historically and there was no spikes. And finally, developers, the approach that they did was having two connection strings and being able to switch their database connection stream from Vitess to TiDB. Once we were pretty sure this was ready, we were ready to go. So the actual live switch, we had 2 minutes of downtime allowed, and the first step was to stop all traffic on Vitess. So this can be done with just shutting down the VTgate proxies. And at this moment in time, the world had stopped. We waited for replication to catch up from Vitess to TiDB. It was almost instant, so that wasn't a problem. And we also saved the GTIDs in Vitess, in each Vitess shard, and the TSOs in TiDB. Once we had this mapping, we told the devs, go ahead, switch your connection. They did, they switched their connection string, and at this moment, TiDB was live, basically. And this was the crucial moment. After it was going live, we had to closely monitor it, and fingers crossed we didn't need plan B, although we had it if we needed it. So right after the migration, things looked fine, with the exception of one query. This query was running for 3-4 seconds. Basically, we started doing a table scan, and the workaround at that time was to use a force index and forced query plan to use the index. This drove the execution time to half a second, and it was okay for our service. Also, we disabled auto-analyze, which is statistics gathering. This can be quite heavy. So initially we disabled it, and then we made it run during the night. And finally, to avoid having extra costs, we downscaled TiDB. We monitored for the next couple of hours on peak traffic times, and things were great. So conclusions. Migrating to TiDB, from Vitess to TiDB was nerve-wracking. It gave us a lot of sleepless nights, but in the end, it was worth it. Mostly because we ended up with a much more manageable TiDB cluster. We had significant savings in infrastructure costs and engineering time. For example, with TiDB, we reduced our EC2 instances to not half, but almost half. Also, we can use ARM CPUs, which are more effective, and scaling is simple, just add more nodes. We didn't need to reshard manually, which is something you need to do with Vitess. If you want to reshard, you have to provision new infrastructure, copy the data, do the switchover. And online operations were straightforward. With Vitess, it's basically the same as MySQL. Finally, internal tools like user management and Kafka feeds worked out of the box. And yeah, we've been running this for 6 months, and so far, so good. It's been running smoothly. So with that, that's the end of the presentation. We have a few minutes for questions and answers. Thank you.
So we will run the online.
Is this one working? Yes, I'm the lucky one this time.
Okay. Okay, it's not HA anyway. So we'll answer the online questions first for this round, then we'll go to the offline audience. There is one question. So how long did it take the DBAs to get familiar with TiDB?
I'd say about 2-3 months. Yeah, we had some internal training, and then PingCAP came along to give us more advanced training. But I'd say, yeah, about 2-3 months.
Right. The second one is, did you need to do any code modifications to TiDB because it's not fully MySQL compatible, or do you have any MySQL compatibility issues?
We had some issues. One issue was actually Vitess was running on MySQL 8, and this had a different collation than TiDB supports. So during the initial loading of the data, we actually had to hack the dump file and change the collation there. And also the order by primary key auto increments, we had to change that.
Okay, thank you. Those are all the online questions. Then we can go to the...
I quite didn't understand about like this exact migration from Vitess to TiDB. Did you write some your own component to do this? Yes, from Vitess to DM cluster, between
from here to here.
Yeah, from the first one to the second. Like, did you write your own component, or how it was done? Like, technically.
We didn't need to. DM is a data migrator. It's a tool from PingCAP, and it reads the MySQL bin logs and applies them to TiDB. And you can actually have things like filtering, merging of shards, renaming of tables. So this was the data from here to here was totally.
So it was no pain, basically easy.
No. The migration went, with the exception of the collation issue, it went fine.
Okay, and then you get some signal from TiDB that, okay, data, like all data is migrated, and then you do switch.
No, you need to also do replication from here for the incremental changes. The initial dump was using DM, and then you had to set up also, you also had to use, the initial dump was doing lightning and dumping and lightning, and this DM was actually used for the replication.
Okay, thank you.
Question about costs. Did you notice any data traffic cost increases in the same region, considering that the TiDB are replicating like data between nodes?
I don't have exact numbers, but I wouldn't expect any much differences, because for Vitess, you also had 3 nodes in 3 AZs per shard. So we had 3 shards or 3 key spaces and 12 nodes in total to support that. 1 node was a backup, 1 master, 2 replicas. For TiDB, we had 9 TiKV nodes. So in general, I would actually expect costs to be similar or even lower with TiDB.
Okay, so yeah, I'm here. Just a little question about the this cool feature about the online DDL that can be applied, as I understand, almost an instant. Like, could you elaborate a bit what stands behind this feature and how it is implemented?
Okay, TiDB internals. Maybe that's a question for TiDB developers. But from what I understand, for example, if you add a column, that'll be in the background changes. The TiKV nodes would have 1 extra column, and of course it's just empty initially. So any new queries that start inserting into that column, it'll just append to the end of the TiKV row, right, Daniel? Or?
So it's like, do I understand correctly that it's like having a Percona online, like this schema change tool, like built in the system? So you you're trying to apply changes. I mean, not exactly as Percona, but I mean. Yeah. Okay.
column, changing data types, etc., is almost instant. I think, for example, if you want to change data type, it changes.
Only one.
Still,
Will it work or not? Should I bring it for him? You can take this one. Yeah.
It's a tough question.
So basically, there are two kinds of changes. Same is true with normal MySQL, by the way, is that some changes really need to modify all the existing rows. Some changes can be done as a metadata only operation. So if you're adding a column, for example, older MySQL versions would just go through all the data and add that one column. And newer versions of MySQL and also what TiDB does is not to add the column in place, to just like have a new version, and once you touch the row, then you update the things. So updating metadata is way faster, of course. For adding an index, that doesn't work. And I also think that for changing the data type, that doesn't really work, because if you're changing something from say a small integer to a bigger integer, that should work. But if you change something from like a bigger integer to a smaller one, you need to verify if all the data still fits in that new integer. So you need to actually scan through all the data, and that's true for many of the operations where you're changing the type. So you actually need to verify the data.
Thanks.
That's the last question. All the speakers will be here. Okay, yeah, so we want to keep the
All right. Thank you, Leandro.
Thank you
for your speech. So, thank you. So, let's do a 15-minute break for networking technical stuff. So let's continue at 7:30. So.
So we have another one. Who's Andres?
All right, ladies and gentlemen, let's get back to business. Let's continue in a few minutes. All right, due to the timing of the event, let's continue with our agenda. So I would like to welcome our next speaker to the stage, Susanna.
Yeah, thank you very much. Yeah, I got this one. Hi. Thank you guys. Hi. Okay. So thank you all, everyone, for being here and the people online. So my name is Susanna. I joined TuBolt a year ago, and I will be speaking today about how we are switching our MySQL databases to TiDB with the minimal service disruption as possible. But for that, for a better explanation or better understanding, I will go through the current infrastructure that we have at Bolt to connect to our databases. And then I will go through the steps that we are doing to migrate to TiDB, as well as some pre-work that needs to be done. And so we have hundreds of microservices at Bolt, and these services use different technologies accordingly to their needs, but obviously I will focus on those ones that use MySQL or TiDB now as their main database. So the package of all these services are deployed into Kubernetes clusters, and all these services uses the same in-house written library to connect to the databases. And in turn, this library trusts in an in-house written system that we call configless, which is an appropriate name because to connect to the databases, the service just needs the username, the host name, the database name, the password are not required because everything is handled by configless. And so none of our developers or DevOps or database administrator needs to handle the user credentials, making our life easier. So we have also tens of MySQL clusters, as well as a bunch of TiDB clusters. And the number of TiDB clusters is growing as we migrate to them. This configless system needs to be smart enough to map each service to the proper database in the correct host. So for that, we are using ProxySQL. We have a ProxySQL cluster that is just routing the connections from the services to the right database. For those who never heard about ProxySQL, I think it's a tool that it works its own presentation, but we use it here at Bolt to route the database connections as I mentioned, to the right cluster and the right host. And we use it as well to divert read-write and read-only connections to the leader or the replicas. And obviously, this is for MySQL, because with TiDB, we don't need to worry about that anymore. But we also use ProxySQL to monitor the health of our backend and just failover in case we need it. But short story, we use configless. It takes care for all the database user credentials, and these credentials are dynamically configuring the ProxySQL routing that we need. So having that as a background, configless, let's talk about migrating into TiDB. So we are migrating one schema at a time. And fortunately, we have this policy, internal policy, that states that each service will use only one schema. So that facilitates the migration. So the first is we migrate the pre-live or staging environment, and the service owners, they run their tests there, they approve the migration, and actually it's them who request to the database administrator to migrate their schema into TiDB when they are ready. And so when they do that, the first task is set up the replication from MySQL to TiDB. We use data migration task for that. We set this task as all, which means we are gonna do a full dump and then incremental replication constantly. And we also have to consider Kafka, because a lot of the data from many of our schemas is fed into Kafka. So we need to make sure the next step will be to make sure that Kafka is also fed from TiDB to Kafka. We use for that TiCDC, which is the service that we spoke about that before, but replicates incremental data from TiDB into Kafka. So once we have the confirmation from our data lake team that we have a proper ingestion of data from TiDB to Kafka, then we are ready to migrate to our live traffic. And obviously some pre-checks, we will notify the owner. They should have their monitors open, be aware of what's going on. We confirm that we don't have any delay between MySQL and TiDB. We will identify the source of our connections, which is ProxySQL, as I mentioned before. And we will test, obviously, the connectivity to all our elements, which is MySQL, TiDB, ProxySQL, configless, and so on. So to guarantee the minimal disruption of the service, we have to execute the checklist in this slide and in the next slide as quick as possible. So the first, in the origin in MySQL, in the leader, we will first drop the users. We drop the users because we don't want that any misrouted connection writes anything while we are migrating in MySQL anymore, and it's gonna fail. So we prefer that than have. So we also drop the users because our configless system doesn't support to have the same user in multiple clusters, either MySQL or TiDB. The users are unique per cluster for this system. Then we will kill active connections in MySQL. We are keeping the log for the replication position from GTID, and we confirm once more that there is no delay between MySQL and TiDB. So in TiDB side, we also kept the replication position. We are gonna create the users that we drop in MySQL, create them in TiDB, updating ProxySQL to route the connections now into TiDB. Make sure that there is no any remaining connections in ProxySQL trying to or failing to connect to MySQL, as we don't have the users there. And the final step is updating our local configless system to reflect the new cluster for each user. As I mentioned before, now after all this, we are ready to send all the traffic is been sent into TiDB. But since the moment that we drop the users, the database service is down. So this is all total downtime that we will have. So basically, we need to be fast, and there is no room for human errors, which being humans is not is not so sure. So the automation for this it was crucial for us, and we did it. This has been done with an internal tool that was named DB Migrator. And so this tool will, as you can see, it's an intuitive tool. It can list the connections from the active connections that we have in MySQL, as well in TiDB, from a specific user and or to specific schema. In this case, we care about the one that we are migrating. And basically, it's gonna do all the pre-checks and the migration steps that we want. Yeah. So this is the way basically that we are doing our migrations. And here, next slide, at the right side is the output for migration completed. And the first half is just showing the pre-checks, which is checking the replication position, is checking which user are going to be migrated from MySQL to TiDB, checking connectivity, etc. So once we confirm that we want to really migrate, it's going to drop the users, kill active connections, create the users in the other side. And so all these steps at the moment is taking between 2 to 3 seconds to complete, which is the downtime that we are having at the moment for live migrations, which is acceptable for us so far. So this tool is written in Golang, and it was built in for our local infrastructure. So we don't have plans at the moment for making this tool public because it's very, it has a strong dependency to Bolt's infrastructure. But I can tell what it's doing. So basically, all the steps that I described before. It's gonna get from process list the active connections. It's gonna have the unique host. It's gonna SSH, open an SSH connections to each one of those, access to MySQL. So it's gonna kill connections and updating proxy SQL to route the connections to TiDB. And at the end, updating our system, configured system, so we don't override these rules later erroneously. And yeah, that's pretty much. Some learnings along the way is from the first migration that we did to the last that we have done. We've been learning and changing and improving this. So be prepared to fix forward all the time. Keep all your monitors open. We sometimes use MySQL query rules in proxy SQL to route these connections or to a specific cluster. Instead, use the user's default. We use temporary query rules. And yeah, that's pretty much the way that we are doing these migrations. Thank you. So, any questions? Thank you.
I have a question about the applications. How do they handle this downtime?
Well, yeah, obviously we inform the owners for each service, and they have their monitors, they have their connection errors. Basically, some of them is between when we kill the users and we drop the users and kill the connections. They have this access denied, basically. Yeah, that is pretty much, and it's for these seconds that we talked about before. They are aware of that. The owners, I prefer. So yes, we have a small downtime for a few seconds.
Thank you.
Yes.
First of all, thank you for presentation. I have a question about configless. Did you consider, of course you did security considerations. So can you talk a bit about this? Because you don't use a password host port for connection, so how you manage it?
It's a quite complex system that requires different teams. So basically the developers create the request for users. The way that they do it, they put into Git a JSON file with the name that they want for the user. And this system is pulling from Git all these users' requests. and it's gonna create the users in MySQL or TiDB, and it's gonna configure later the routing in proxy SQL. So basically, when it creates a user, it has a random password, and when the service is requested, they know exactly which schema. So this information is in the request. So we kept just the track or the map from which user, which schema, in which cluster is being done. And this configuration is then later dynamically configured in proxy SQL. So basically, it's just the intermediary between having this request, creating what normally database administrator does. But yeah, no, it's quite cool because it keeps all this information in S3 buckets that later is configured in proxy SQL.
Last question, does it manage user privileges also?
Yes, it does. It does per schema. So as I said before, we have an internal policy that we use one schema per service. The same schema can be used for multiple services, but the service is only for using one schema. So yeah, it has for services almost all full privilege for that schema specifically.
Thank you.
No problem.
Do we have anything online? All right.
Cool.
There
Thank
is.
you.
Yep.
Hey,
Hello.
are you able to share something from like the beginnings where TiDB at Bolt went from being just an idea somebody had to actually gaining the momentum to, you know, push it through all the way to production and to where we are today? And like a follow-up related question for me is, did this originate from the DBAs or application engineers?
Yeah, you mean the decision to migrate? Like that is database administrator determined that we cannot estimate how fast or not is going to grow our data. So we prefer to migrate to TiDB. But the owners of the data at the end of the day is the teams and the developers that owns that service. So it's them who request to us to migrate. We have the platform to do it, but it's their decisions to migrate. Obviously, as a business, is the technologies that we agreed to use.
Yeah, so I was wondering for the companies, I think for the rest of us in the room who are in companies who might be interested, but going from this idea that, hey, there's this cool technology that solves some problems, the step to actually getting it usable for engineers is quite long. And I'm wondering, like, how did it go for Bolt's case?
Okay. Yeah. Yeah, he's a lead for this project.
So the initiative as such, sorry, hijacking the microphone.
No, please.
So the initiative as such came from database team. Because, I mean, developers, with all my respect to developers, they want to store the data. They don't want to manage. They're pretty far from the pain to manage and keep the availability and things up and running. So this initiative actually came from the database team itself. So basically the aim was to find something that developers wouldn't notice. That's why the MySQL compatibility was the main idea. Of course, there was the Vitess era where there was a huge backend code based change. But with TiDB, it was actually pretty smooth. One of those migrations was done so that it's incorrect, but we didn't inform the team just to test out, and they didn't notice. So this means that the compatibility as such at one point in time is something to look into this, but don't trust it because there are some like pretty bad loopholes. But to answer to your question, that was the database team.
Yeah, and the transition, it wasn't that easy. It's like that guy Guido just create like a swap team. It's like a DBA is dedicated fully deep into learn the technology and learn the requirements that we need. And then this knowledge was transferred to the rest of the team in the database team. So yeah, it took that full time for a couple of DBAs for a few months, and then the knowledge was shared. So it was
The online audience said, good job, DBT.
Ah,
Yes.
thank you, guys. Thank
All
you.
right. Thank
Yeah.
you, Susanna, for your speech. So now is the time for the final speech of the event. Andres, please welcome Andres to the stage.
Hello. As you can see, my name is Rudolf, and I'm going to talk about how late lighting is. Oh, sorry, this is not Santa's conference. Okay. So my name is Andres Kepler, and I'm going to talk about TiDB custom metrics, what we did. And before I will begin, I will talk about myself, and later I will explain why we did it, and how we did it, and what is a result of this custom metrics. So about myself, I have been more than 12 years as a system administrator, and also some more than 3 years as a manager. And my current responsibilities as a developer, I'm developing in-house tools for the DBAs. All this code that was previously presented, but not all my origin, but I'm helping them. But my preferred language is mostly Python and Golang. Let's talk about a little bit Bolt. As previous presenters also said, that we are around the world more than 45 countries, and we are located in more than 500 cities. We have 5 verticals: rides, rentals, delivery, drive, and market. Why I'm talking about this is all these verticals are producing hundreds of gigabytes, and we are storing multiple, not even hundreds of terabytes of data daily basis. So, and this, coming back to this previous slide, what is an idea, and that Susanna also mentioned, that all these verticals and services are data owners, and we are, as a DBA's year-to-year responsibility is around the simplicity, resilience, and availability, and scalability, and all these kind of fancy words. But what it means is we are providing infrastructure for the developers and all of the verticals that could be always available around the clock. So why we did it with exporter, or let's say custom metrics? Let's think about it and get some data. So we have already 1/3 of the data is stored in TiDB, and 1/5 of schemas is located in also TiDB. What it means is what I said previously, all these teams would like to get some information about schema-based, for example, latency, and that this is some information we would like to share. But let's think about it. Is it useless, or do we need it? But our idea is we would like to share it, because sharing is caring, and all the data is already available for a TiDB, and it has already, TiDB has a very good ecosystem for the metrics, but this is very good for the infrastructure owner. But in shared environment where multiple schemas are in one cluster where is a lack of information, and we as a database infrastructure owner would like to give some information for schema owners. So how we did it? As I mentioned before, that information schema is already there. I suppose as you know that in MySQL it's also possible to query some information schema, system information schema, but in TiDB it has some custom things already in place, and information is available. And for example, it has some cluster statement summary. It also has a statement summary. It based, for example, instance-based, but in cluster statement summary, it contains all information about all the cluster. And it also has some slow queries information and some errors and bunch of statistics and health and etc. So why we chose it is it doesn't, as far we are tested it, it doesn't affect any cluster performance. Previously, Leandro said that we turned off this analytics. Latestly, I turned on again, but it didn't affect anything, and we are still good. This information schema has lots of enrichable data sets. Here some information about latency. It has also some result rows, and it can be also you can with digest information you can basically see all the query plan. And what is last but not the least is it has a very good documentation online available. So what we did it for us? So very simple. We have already MySQL the exporter. It has some compatibility. For example, some table sizes, it's very well working, but it lacks and even don't have information about TiDB specific information that's available, for example, cluster statement summary. And why we chose it is it has very well integrates our ecosystem, and it integrates into TiDB also. And what is also very good, this framework contains very well test coverage. And this is something what is useful for the developers to add no more features, for example. And the end result is for the 2 months I wrote some not so many lines of codes, but it's something, and it produces something about 100 unique metrics. But I can tell you that per TiDB cluster instance, it in our production system can produce more than 10,000 metrics. That is mostly quite big number, and can be get overhead for the Prometheus. And yes, here is some examples what we are scraping for example every 15 seconds. And here are some examples where I trying to understand what is unused indexes available and I'm exporting it to Prometheus. some examples where we build up with Grafana dashboard for the Shima owners, and there is a good option for them that they can deep dive if they have some latency on specific statement, and it's very, very useful, I think so. So, and here is some examples of where we are giving information about TiDB. It's always information available from cluster statement summary. All the information is just exported to Prometheus. And this is my, let's say, greatest thing what is yesterday we discovered that everything is not very good, and what is the rise here? Something went south basically, and our exporter produced too many different labels, and it was too much for Prometheus, and Prometheus died. So it wasn't very pleasant. And we need to find out how to resolve it. And more thingies we would like to implement is publish it into upstream. Right now this code is not public yet, but as previous slides you can read that it has a very good option, open source option, and we can deploy or publish it as open source. And that's it. Do you have any questions?
Yep. Hi, thank you for the presentation. From me, I have a question, have you performed some kind of investigation what metrics are needed, or you just grab everything that is provided by this, for example, information schema? So the question, was there any analysis?
All these metrics what we are collected here is needed. Together with Andrei, we did some investigation, because if I would like to export everything, it will immediately break Prometheus, because it has lots of different labels, and what is important for Prometheus is cardinality change.
Yeah.
If cardinality change is very big in a certain time, when you are this Prometheus not saving the data to the data store, and it will be kept in the memory, as you can solve from this graph, and this will explode your Prometheus immediately. So we discovered that these metrics are useful, what I showed, but labels should be static, because the vector what we are producing should be static somehow in some time period.
Okay, thank you. And maybe one last question. Is it a shareable information? What was the source, what was the root cause for such a spike?
Yes. Here it is. This one.
Plan digest.
This produces for every label different.
So it's kind of random.
Yes.
Value. Okay. All right. Thank you.
Yes.
So if I'm looking at process list in a TiDB node, I can see that the process list reflects only active queries which are going to that particular TiDB node. Is it the same with information schema table as well? Meaning that do you have to scrape from every TiDB node, or is there?
Yes, we deployed it to every TiDB, not TiDB, to TiDB node, and but we can scrape cluster schema, cluster everything what starts with cluster. There is available all the information what is in cluster and what is the difference from cluster and statement summary. Is cluster summary contains information about node.
Thanks. And are you scraping like TiDB nodes as well, or this information is already available in TiDB nodes?
It's available in TiDB nodes. It's all this information. You can look at, for example, from here, from the example, it has some TiDB information written already. What is for example, if I'm not missing, is maybe it's RocksDB information.
Thanks. Right, do we have anything online?
So, thank you very much.
I have one more question.
Oh, okay.
It's pretty easy about, again, latencies. Is this only average and maximum available? Also percentiles possible to get from this class information? Because like it looks like just average and maximum is not fair enough.
Yes, what is the current query is doing is
so you have average, maximum,
yes,
and
average,
sum of latency.
average, yes. And what is here is a missing basically is a grouping by the digest. And this is an average when all the statements together.
Okay.
And this is maybe some trick, but it's can be also summarized or whatever we and what I'm saying also we are still in work in progress and discovering.
No,
it.
I mean like is it possible to get some already from this current cluster statement summary?
Yes, the implementation is very simple right now.
Yeah. No, I mean like is this cluster statement summary is built by the TiDB, yeah? Yeah. So is it have already built some percentiles, latency or something like that? Or is
this is aggregation. This is aggregation about how you are doing in how you are doing it in Prometheus.
No, I mean usually it's like some histograms used for like collect stats and then build some queries less than 50% of queries less than that time, 95 or it can be buckets or percentage.
What you are talking about, but if I'm trying to dig in my memory, then it has this kind of information, but it's lacking about what our goal was give information about schema and table. But this percentile information is available per cluster level.
Okay, so you can just collect by query or something like that.
Yes.
Okay, yeah. That makes
but
sense.
It needs some extra aggregation to calculate it.
Okay, yeah, thank you.
All right, I think that is it. So thank you, Andres, for your presentation.
Thank you.
And to give the final words, I would like to thank you everyone for joining our meetup event today. This was a really big event for us. So once more, thanks for Bolt team to organizing this with us. And we still can use like 20 minutes or more for the premise and answer all kind of questions. And please feel free to take all the t-shirts, pens, and we also have stroopwafels directly from Amsterdam. So please do not forget that. And Daniel, I think you might have something regarding Slack channels and.
Yes, so we have a TiDB community Slack channel, slack.tidb.io. And also if you go to the PingCAP website, you will find a Slack button on like bottom right, I think, or bottom left, you will find it. So there you can ask any questions and then we will try to answer them in the next few days. We also have TiDB Cloud. TiDB Cloud has a free serverless tier, so you can try TiDB for yourself. You can also go do tieup.io, and there you can just install TiDB on your own local machine if you want, and try it that way. Thank you.
And I think I've been approaching many of you through LinkedIn, so feel free to approach me if you have any further questions. There is also my card with direct email and phone number. But thank you.